Hello everyone, welcome to Digital Logic Design Simulation Based Project. The project topic is Room Security and Automation System. This project is presented by MD Sirajuddin Borno. This course was instructed by CHOWDHURY AKRAM sir. Let's explain the scenario. There's a digital lock on the door of a room. To enter the room, someone must enter a 5-digit PIN. The lock takes only binary numbers as input. If 5-digit PIN is given correctly, the door unlocks. Inside the room, there's a motion detector. If the motion detector detects any movement, then the light bulb will be turned on, and also check the room temperature. If room temperature is high, then air condition is also turned on. Now, if someone gives incorrect PIN to the system, will show wrong PIN. After giving incorrect PIN 3 times in a row, the system will notify the owner and the alarm will go off. But if incorrect PIN is given before 3 times in a row, the counter resets itself. That's another security option. If the door lock is not checked but there's movement inside the room, the alarm will go off and notify the owner. To solve this problem, let's break down it. Making a password / PIN checking system that checks 5-digit input. Making a counter that can check number of times wrong PIN is given. Making an alarm that goes off if n number of times wrong PIN is given in a row or there's any unexpected movement. Making light bulb and AC that can be turned on conditionally. Combining all the above mentioned small systems together. To solve that problem, we need something that can check if all the inputs are same or if all the inputs are matched with the stored values. We can use XNOR gate for that. We can make a counter using JK flip-flop. Alarm system can be made using few logic gates. Light bulb and AC can be turned on with logic gates. The components we need to simulate that project. To input XNOR gate need 5. We need 5 input AND gate. We need 6 and 2 input AND gate, 4 NOT gates, 2 JK flip-flops, 5 probe lights and DCD hex. Let's jump to the simulation. Let me show you why did we choose XNOR gate or other gates. XNOR gate has a unique property that will help us build this project. Only XNOR gate gives output high when both inputs are same. It doesn't matter inputs are high or low. If they are same, the output will be high. So as you can see, we can set this one as a stored value, and we can set this one as inserting values. This way we can check the inputs with the inserting values. And if we take, so this will work for only 1 bit. So if we want 2 bit, then we can do this. Now those two values will be acting as input values and these two will be acting as stored values. So our stored value is 0 0 and input value is 0 0, then the output is high. But if the combination doesn't match, the output will be low. So now we can take as many as number of pin we want. Now let me show you how the counter works. We'll be using JK flip-flops to build the counter. We will be taking this clock, we are making asynchronous clock, so there will be only on clock, and we can take this one as our inputs. So in this clock the inputs will be same for both the flip-flops. And this will go here. But to make a counter, we normally use negative edge JK flip-flops. We don't have a built-in negative edge flip-flop here, so we will take a NOT gate and make this a negative edge. Let's see if the output is working properly. We have taken DCD hex to show the output. This is showing true first, so we will use 10 Hz. You can see 1 2 3 1 2 3. So it's working properly as a 2-bit asynchronous clock. Now I will show you the whole project. So these are the stored values, these are the inputs. We have the dot checking here, motion detector, room temperature, alarm, and the hex counter is here. Now let's see if all the condition checks. Here the input are same. Let me change this a bit. Stored values is 1 0 1 0 1. So this output is this input is all 0. The password is not matching. Let's check. We are using key A to check. So the inserted input was incorrect and the counter shows 1. Let's try another combination. This input is also incorrect, so the incorrect LD shows and the counter shows 2. And now we are giving another input, another wrong input, so the counter says 3 and the alarm goes off. Now let's try with the correct inputs. We have 1 0 1 0 and 1. Let's check. We have the input correct. Now if we have motion inside the room, then the light goes on, and if the room temperature is low, the air conditioner will not turn on. If the room temperature is high, the air conditioner will turn on. Another feature of the security is if someone gives correct input before giving 3 wrong inputs in a row, the counter should reset itself. So we'll try with wrong inputs again. Just changing this, checking. The counter says 1, giving another wrong input, checking, counter says 2. Now giving the right input 1 0 1 0 and 1. Let's check. The input is correct and the counter resets itself. Another option was if there's motion inside the room but the door is not checked, then this alarm should go off. To do that, we will turn off this check and the motion detector is high, so the alarm goes off. Thank you everyone. This was my project. I have another video in this channel where I have explained in details and build this project from scratch. What components I am using, why using them, and every connection. I have linked that video in the description. Thank you for watching.